Good day everyone! I am Sir Alkrismit. Welcome to my channel where fun and learning really do exist. Kung bago kayo sa aking channel, huwag kalimutang mag-subscribe, hit the bell para laging updated sa aking mga videos, i-like, share nyo na rin sa mga friends nyo, and mag-comment na rin kayo. So now, let's begin! In this video, we will continue the discussion about Unit 1, Earth and Space, Module 1, Plate Tectonics, and the topics to be discussed here are about Divergent Plate Boundary, Transform Fault Plate Boundary, and Hotspot. Now, the second type of plate boundary is called Divergent Plate Boundary. As you can see on the figure or the diagram, the two arrows are in opposite direction. So it indicates, or they indicate, that the two plates are moving apart. So when the two plates are moving apart or moving away from each other, their boundary is called as divergent plate boundary. So what happens in the divergence of two plates? Divergent boundaries occur along spreading centers where plates are moving apart and new crust is created by magma pushing up from the mantle. So what does it mean? If a divergent boundary is between continental plates, the effects are shallow earthquake activities and numerous normal faults. Rift Valley formation which will soon develop into linear sea. Effects that are found at a divergent boundary between oceanic plates include shallow earthquake activity, submarine mountain range such as the Mid-Atlantic Ridge or the Oceanic Ridge. We have volcanic activity in the form of fissure eruptions, creation of new seafloor, and widening ocean basin. So let's explain the divergent plate boundaries using this diagram. So remember that it begins with a whole continent. So there will be earthquake because of the shaking of the ground. There will be upwarping on the ground, and then normal faults will be produced because of the pressure of the magma, the rising magma. And then the plates will now move away from each other. So divergence of the two plates continues, and there will be Rift Valley that will be formed until that Rift Valley will become linear sea. Then under the sea or underwater, divergence continues. There will be rising of magma, and then cracks will be produced, and then there will be fissure eruption. So on those cracks, on the oceanic crust, magma will flow out, so there will be lava. And then since underwater there will be low temperature, the lava will harden or solidifies. It will form the new ocean floor, and then divergence continues until the seafloor or the ocean floor will be widened. So there will be widening of the ocean basin. So palawak na siya ng palawak. Ayan. So that is divergent plate boundary. Again, divergent plate boundary where two plates are moving apart, moving away from each other. Divergence. So the third type of plate boundary is transform fault boundary. Looking on the diagram, the plates are sliding or grinding past each other. They are not moving apart, nor they are not moving toward each other. So it is called as transform fault boundary. They slide or grind past each other. That is called transform fault boundary. So what happens along that transform fault boundary? Transform fault boundaries are where two plates are sliding horizontally past one another. Most transform faults are found on the ocean floor. They commonly offset active spreading ridges, producing zigzag plate margins, and are generally defined by shallow earthquakes. Only few of transform fault boundaries are found in the continents. The best example of it is the San Andreas Fault. San Andreas Fault is located on the western part of United States of America in California, San Francisco. So we have this one which is called a hotspot. This is another concept in plate tectonics. A hotspot is an area in the mantle from which hot materials rise as a thermal plume. So based on the diagram, so we have this mantle plume. This is the magma rising above the crust. Ayan. High heat and lower pressure at the base of the lithosphere or the tectonic plate facilitates melting of the rocks. This melt, called magma, rises through the cracks and erupts to form volcanoes. So remember, if the magma from the mantle rises above the crust, so there will be volcanoes. So if the volcano erupts, lava will flow, and then it will solidify, and then another magma will go out, lava will pile up on the volcano. As the tectonic plate moves over the stationary hotspot, the volcanoes are erupted away and new ones form their place. This results in chains of volcanoes such as the Hawaiian Islands. So remember that the plate is moving, so indicated by this arrow. The mantle plume or the hotspot is stationary, meaning it is on that position. It never changes. So this volcano is formed here. So since the plate is moving, so the position changes. So long time ago, this volcano is in this position, and then as the time goes by and the plates moves, there will be new volcano on top of the hotspot, and then the plate will now move again. This volcano will be in this position now, and then another volcano will rise or will be formed, and then move until we have several volcanoes. So this is called chains of volcanoes. So we have that chain of volcanoes. Example of that is the Hawaiian Island. So since module 1 is already done, you can now answer the following questions correctly. The first question is, how do you describe the distribution of active volcanoes, earthquake epicenters, and mountain ranges? So how do we describe the distribution of active volcanoes, earthquake epicenters, and mountain ranges? Number 2, how do you describe the different types of plate boundaries? So we have 3 types of plate boundaries, and how do you describe each? And the third is, how do you explain the different processes that occur along the plate boundaries? So if the two plates are converging, what happens? What are the processes? If the two plates are diverging, and if the two plates have a transform fold boundary, what are the processes and geological events that occur or happens? And that ends our lecture about plate tectonics. And how was that? Did you get it? Are you sure? Do you still need help? If you still have questions on your mind, you can watch again our first video and this video so that the concepts about plate tectonics will be clear to you.